Sorry I'm late. Panicked 111 students wondering if they still had the possibility of passing after not turning in projects, assignments, or labs.
Like all of them?
Yeah, the majority of them.
I was actually going to ask you the same question.
Oh, that's why I love you all. All right. So, been getting some questions on the project. That's good. That means that you all are diving into it. You want to ask me some right now?
We have questions that we don't know we have until later.
Huh?
Seems that we have questions that we don't know we have until later.
Well, that's kind of the way of things. I guess as a matter of just trying things out, if there aren't any questions, we can try out that fire up 2 vagrant machines. Should we do that?
Yeah.
All right, let's see. Where do I want to do that? I will do that. I'll do that here in today's working directory. And what else do I want? We want to play with the client and the server, so let me go up one. What are those file names for those sample socket programs?
Server SCP client.
Okay, thanks.
Yeah, that sounds good.
Unless I change it. Unless I changed it from my server again.
Client and server.cpp.
Were those part of?
Part of the robust read write.
Robust read write.
Yeah.
Okay. "39 files to edit." Whoops, I'm in the wrong directory. Okay, what do I need to do to this? Do these work out of the box? All right. So, I want to say, what do I want to say? I want to go to the daily diatribe. Two vagrant boxes.txt. This URL. Oh, I actually did this a little bit earlier, so I've got it right here. This is the URL. I'm going to copy this. Come in here, I change this to, what is it, Tade, Gibson, CSCI, is it that simple?
Yeah.
Or-
Gibson 4540. Yeah, it's 4540.
Oh, FOR.
Yeah.
All right, so they're called alpha and beta. Vagrant, let's see, so I want, let me exit out of here, All right. So now I'm going to say vagrant up alpha over here. I don't know what the ramifications are of taxing this thing and doing them both at the same time, but I will. Everyone looking forward to summer?
Yeah.
No matter how bad it gets, there's no keeping it more than 3 weeks away. Well, we talked about that, and you all are trying to convince me that I should wax philosophical over stuff I've done with curses before. You want another assignment? I do not plan on dumping a ton of stuff on you. So you can rest easy with that. All right, come over here. Let me look at the vagrant file. So alpha is, let's say alpha is the server and beta is the client. So the client wants to connect to 10.0.0.10. So we'll change this to 1.0.0.10. Vagrant SSH. Whoops, that isn't going to work because we don't know whether it's alpha or beta. Vagrant SSH alpha. Vagrant SSH beta. CD vagrant. There's those. CD vagrant. Let me go ahead and change the prompts here. Let's call this one client. That'll help remind. All right, make client. Make server. Doesn't matter which I do. I could have done both here. All right, so this is the server over here. Client. Oh, thought I did. No, this is it might be in a little too old school. What is it, IPA? This is 11 over here. That means that this has to be 10 over here. I guess we can Control C it. That's 10 over here. We can ping each other. Oh, yes. All right, that saves me from some.
When you pass null in there, does that just get itself? So I think on the server that it's null. I think. Yeah, null pointer. So is that itself or just any?
Yeah, I don't need. Well, let me not speak out of turn here. Oops. Node is not null. Let's see. Here, a socket that'll, so if it's null, it'll be a socket that can accept connections. All right. Two machines talking via sockets in under 10 minutes. So that should be straightforward. Now I did do this in a separate directory, and you're certainly welcome to do that. But let me remind you that what makes Vagrant wonderful is that really what I'm using it for is kind of its basically its virtual operating system, what it provides, right? It's giving me a Linux operating system rather than this Mac that I'm on, and that I am, where am I? That /vagrant is this directory right here, right? When I do an ls, and then on my Mac I do an ls, they're the same. So as long as I'm disciplined and I put all of my work in /vagrant, I can destroy my virtual machine without affecting any of the work I've done. So I hadn't done it, but I would have been fine if I'd remained in the directory I have been all semester and just simply said vagrant destroy and totally destroyed that virtual machine, and then put in this new vagrant file and then brought up the two, right? So destroying a virtual machine shouldn't hurt any of the work I've been doing, since all the work I'm doing is in my host file systems directories. One reason for considering that is that if I go up to my home directory, there's a vagrant directory. Gosh, I keep doing that. So here's 700 meg.
1.9 gig over there.
Right, I'm getting, I'm basically, so these are all the 540 boxes. Right, I'm eating up gigabytes worth of disk space when I do this. So that's a reason why you might not want to proliferate a ton of these boxes and just destroy it if you don't need it and bring up a different one. Stop that. All right. So, what y'all got for me? Yeah.
When we test like signal handlers in the vagrant system, like a simple SIG-int catcher program.
Well, I don't have to do a simple one. Why don't I just run a game?
Oh yeah.
If I go to here. So it looks like the signal handlers are working fine to me. Constantine asked me to confirm that signal handlers indeed work on these virtual machines. And yes, it would be useless for me to make everyone work with Vagrant if they didn't indeed. Oh yeah, first try. Go over here, get rid of that. No, this isn't that's a Project 3 version, not the Project 4. The answer is no. You're not sending the whole map over. You're sending a list of pairs of changed bytes.
Oh, okay.
Pairs, the pair being the offset and the contents of the byte. And that should be so that's what to do. Yeah, so the identifying byte is 0, and then a short, which is the number of changed map squares, and then for 1 to n, the offset and the byte are sent. What else?
I remember there was a question about how would the daemon tell the game process if it fails to establish a connection.
On the client side.
So I think that it would first, before forking it, would get the PID of the game, and since local variables are preserved between forks, then it would just have the ID of the game, then it would send it a signal.
Yeah, you could do that, or you could get the parent ID, like you suggested in Piazza. All right, either of those strategies works. And then we've talked about it, but let's talk about it again. So on the client side, when the first game process on the client side starts, almost immediately it spins off a daemon, and that daemon sets up everything, and then only after everything is set up does that client game proceed forward and, quote, plays dumb and sees that there's shared memory there already and just kind of joins an existing game.
So that's the same thing basically, just sending another signal, a different one, to the parent, to the game process, right? To tell the game process when it can proceed.
So that's my question is, what are some ideas for strategies to get the game process to cool its heels while it waits for the client daemon to spin up and get the shared memory in place?
Like your idea of like getting the value of the sound, waiting for it to be grabbed or whatever, not available, and then have that in a while loop, and as soon as it sees that the symbol was grabbed, just jump out of that and go to a sim wait.
Another yeah, I thought when I was reflecting on it, I was thinking of a slightly more graceful way of doing it is let's see, you couldn't do that.
I have a possible solution.
Yes, sir.
I think there's I don't know the name of the function, but there's a function that's like you wait, you go to sleep until you receive a signal. So it's not a busy wait, it's more efficient. You just go to sleep until you receive a signal. I would suggest the sig-quant signal. The sig-quant signal. It means
The sig what signal?
Quant.
Spell it.
C-O-N-T.
Oh, continue?
yeah, continue. So I don't know the name of the function, but I know I've used it before. A function that waits until a signal is used.
Yeah, I think that could be nice. You could do other variants. So regarding the semaphore, you could actually have the client go ahead and create the semaphore, do a sem wait, have the client then spin off the daemon and immediately do another sem wait. Now that client's going to hang until the daemon sets everything else up except for the semaphore, and then the daemon does a sem post, which allows the client to proceed. It's another one.
I was thinking that, but like, you know, so to have the client, you still have to wait to make sure that the client or that the daemon grabbed the semaphore, because in the potential race condition.
Right. So the while loop was, well, that would avoid a race condition because you don't spin off the. So the disadvantage of it is you're having the client game process create the
Semaphore.
right. The advantage to it is that there'd be no chance of a wait because, again, the order is game process creates semaphore, game process does sem wait, game process forks off daemon, game process does sem wait. That second sem wait it's going to hang on. Meanwhile, the daemon does whatever it wants to do, and when it's done, it does a sem post, and that releases the client. So keep in mind what sem wait and sem post is doing. What sem wait and sem post is doing is it's merely changing a shared resource. It's not owned. If I do a sem wait, what I'm doing is I'm decrementing a shared value. I don't own it in a system management sense. The only reason we think in terms of owning it is because we agree to create cooperative processes to patiently wait if that value is not there. But I can go ahead and do sem wait, and I'll definitely freeze until someone else does a sem post.
Mm-hmm. Oh, yeah, because when you fork some off, that'll also have.
Right. So when the daemon, you fork off the daemon, you're right. You wrote the code, so you know that. You know that the client is waiting for there to be a post. So the daemon doesn't bother with a sem wait. The daemon just goes ahead, sets up everything, and then does a sem post. So that's another way. So and then the sleeping until signal could work. So there are all sorts of strategies you could use to ensure that your client game process waits until the client daemon is done initializing.
Do we have additional players running on the server side?
You can have anywhere from 0 to 5 on the server side and 0 to 5 on the client side, where the maximum number of players doesn't exceed 5.
Okay.
So it's possible, it's actually possible to start up a player on the server, then start, say, 3 people on the client, and then have the server player quit, and that server daemon will still be running, right? Neither of the daemons quits until there are no players on either side.
So the demons need to send both each other no. So if all players quit on one computer but not on the other computer, that other demon needs to stay there.
Yes, but you don't have to do any special processing to handle that, because I've already written that into the protocol right here under daemon behaviors, I think. It's this one right here. If you follow this algorithm faithfully, you can't go wrong. So you're gonna get a byte when someone leaves. So let's say that you are the very last person and you leave the game. What that means is when you leave the game, if you recall from the very beginning, initial gameplay enhancements, you're going to send SIGHUP to the daemon. So you're the very last player, you send SIGHUP to the daemon, and then that daemon is going to assemble a byte and send that to the other daemon. So that byte is going to be devoid of players. All right? So meanwhile, that other daemon receives the byte and does comparisons for each bit and checks to see if a bit is on. None of the bits will be on. There are no players. If a bit is off and shared memory ID is not 0, then that means a remote player has quit, which is exactly what happened. What you do is you close and unlink the message queue. You set the shared memory ID to 0. Once you're done looping through there, check the value of that single byte. Note that you don't check the value of that single byte until you've done this looping, because why you do this looping is it's helping you clean up all these shared resources. Once you've done that loop, check the byte. If that byte is actually equal to GSOC player, which is the bit that lets you know what this message is, then no players were left in the game. Close and unlink the shared memory, close and unlink the semaphore, then exit the program.
What exactly do you mean by shared memory ID?
The player.
Array.
Oh, okay.
I think it's in the array.
It's the array, the array of 5 PID types.
Okay.
That's poorly worded, isn't it? It should be more specific about that. But that's what that is. That's that array of 5.
And it checks that because so the daemon needs to have its own copy of the entire shared memory. Right? In case to check in case like a process on the same machine sends it a signal.
But a process on the same machine will clean itself up on the shared memory, on the local shared memory. Think of the way your Project 3 game works. When it quits, does it not clean up shared memory? Meaning removing its process ID and removing its byte from the map. And that code doesn't change, so that still happens. So
Okay,
what
so
happens
it
is,
takes that one lays the bit and says, okay,
so the local player cleans up and then sends SIGHUP, right? And that's actually worded very specifically here. Right, after the process ID has been set to 0 and the
So the
player
only
remains.
thing the daemon needs a local copy of is the map.
That's correct. The only thing the daemon has a local copy of is the map, and that is to be able to find different pairs to ship across the socket.
On the stack or in the heap.
Right, probably in the heap since you don't know till runtime how large it is. Yeah.
So, even if it received Jigsaw player without any player bit set, knows that all the players on that other machine have quit.
Mm-hmm.
But if there are players still playing on my own machine, the demon.
Then all those bits will not be off
No, but,
because
the bits that are sent from the other machine. They represent the players set on the other machine, not on my machine.
let's look at the picture. Let's see. Open. Oh man, this whole semester I could have been using this awesome clipboard. There it is. All right. So quick refresher here. These polygons represent the demons. Not important. What is important is that this machine has 3 players. This machine has 1 player. These structures up here represent 4 of the 5 elements of the array that keeps track of player process IDs. There are only 4 here because the 5th one is assumed to be 0. Yes? If player 3 leaves, or it doesn't matter, let's say player 1. If player 1 leaves, which bits are on that are sent over here? Now the GSOC player bit is on, or is that right? Yeah, the GSOC player bit is on because that's tells you the nature of the message. What other bits are on if player 1 is left? 2, 3, and 4.
3 and 4.
Well, because 2, 3, and 4 are non-zero in this shared memory. This one receives 2, 3, and 4.
Oh,
It does the loop and checks every single bit. 4 is on, my 4 is on. 3 is on, my 3 is on. 2 is on, my 2 is on. 1 is on, whoa, my 1 is off. Right, because it didn't turn it on when it sent it over. So now it goes ahead and it removes the message queue for player 1 here. Yes?
So the right demon received from the left demon that the bit for process for player 4 is on, but player 4 is on my machine.
It doesn't matter. Doesn't matter. Let's read this again. Let me see. That's more talking about receiving it.
All active players.
Right. The GSOC player bit ORed with all active players. Doesn't say whether they're a remote player or a local player. It says whether they're active.
So if the one of those player positions has the demon ID, that player bit is not ignored.
That is correct. If it shows the demon ID, it is not ignored. You're not distinguishing.
Mm-hmm. Yeah, that wording. I thought that only applied to local players. Yeah. Yeah, that makes sense.
Mm-hmm.
So, like when you move around and you want to send that uptake to a remote player, you kill to send something to the demon, and then the demon iterates through shared memory to find which bits were changed.
It iterates through shared memory, comparing the shared memory's view of the map with the demon's own local copy of the map.
Oh, okay.
It detects some differences. In the very least, you should have 2 differences, where the player was and where the player is. And so you go ahead and send that information across. And then as part of that workflow, you update your local copy to reflect that in shared memory, so that you don't keep sending the same changes over and over again, obviously. Yes?
Oh, are carrots part of like a library or something like that?
There is a pair type. Boy, this is cheesy. Who wrote that? Let's go to this one. Just find our example code, which is so you could create some sort of list of these pairs as you march through, or you could create a vector and push back a pair with each one you construct as you're marching through your local and shared maps. And then when it comes to sending it, you aren't sending this pair object across. You're sending, you'd basically look at, see, you interrogate it with first and second. So you'd have a loop and you'd send first followed by second, first followed by second.
And then the client or whatever will expect first, second.
Mm-hmm. Yeah. Since you're writing the protocol, you know the exact order things are coming in. Yeah.
I think that when you posted how he had a problem with the display, right?
Yeah, the new mapping screen.
Fix it. Oh.
Yeah, the problem was an older copy of the map that I accidentally sent out.
2011.
And so the problem with that was, we can look at the new version of map to identify that problem.
I actually think that's it.
Oh, yes.
I actually think I have a feeling of why it had that problem, because when it interrupted the post notice function, a signal, it would automatically return, whereas in the new version it would just stay in that post notice function. Maybe there's a loop, I think. While, yeah.
Yeah.
This is too wild with that.
I think the version you had it still had the loop, but it had an if statement that allowed basically the signal to bail it out of the loop. So that's the reason for the loop. It's just as read and write can be interrupted by signals, get ch under the hood obviously is read. And so what's happening is the read is getting interrupted by a signal, so get ch is being interrupted by a signal, and so it's bailing out of get ch. And the while loop keeps it in there until you hit the space to dismiss the box.
So is all of that just like n curses stuff? Like your y coordinates, coordinate, window, panel?
Yeah, well, all this stuff's arithmetic. So this isn't n curses per se. This is just arithmetic for me to center the box.
But I mean like the objects and
This window, the window pointer, panel pointer are definitely n curses. New win is n curses. New panel is n curses. Box is n curses. This move w print w is n curses as well. Delete panel, delete window, panel refresh, those are all n curses. And so that's what I tried to do, mostly successful, but not 100%, but nearly all the n-cursive stuff should be in screen, and then map would sit on top of that. Map should have very little n-cursive stuff in there.
also noticed earlier you called make without a make file. You just called it on.
Make client.
Yeah, yeah.
You can do that.
Just like C++ or.
So this is on my Mac. That's why it's saying C++. I did it before on the virtual machine, and it did G++. So it's not ideal, right? I don't get the 2017 standard. I would if I aliased it. You can create a bash alias so that whenever you type G++, it's G++ with whatever other crap. That's what ls is. Let me see. That's what it is. Where am I? Alias. When I type ls, it's actually doing ls color equals auto.
So does make just look at the file extension and then decide which?
Yeah. Make has a little built-in intelligence in it to look at that. If it's a .c file, it'll run a GCC instead of G++. So it's nice for a quick one-off compile.
But it just uses whatever your system default C++ version is.
Yeah, it'll be affected by the system.
That's cool.
Anything else? Alright, well, I will kill the recording, and if you want to harangue me individually, you're welcome to. So we've got Thursday, and then this thing comes due over the weekend, right?